In this lesson, we will look at code blocks in Dynamo for Revit and Dynamo Sandbox. Code blocks are a unique feature in Dynamo that brings together visual programming with design script. Design script is a text-based language for computational design. To get started, we will start a new blank Dynamo graph. So we'll just click on New. Once we have a blank graph, we will add a number, string, and formula node to the canvas. And we can search for these nodes in the library. Number, string, and formula. With these nodes placed, we will go ahead and position them so that way they're organized in a way that we can see each of their outputs. Now that we have these nodes placed, we need to enter the correct data type into each of the nodes. We'll start with the number, and we'll enter 5. In the string, we'll type hello Dynamo. And in the formula, we'll put 4 asterisk 2. In order to visualize these results, we will also need 3 watch nodes. We can search the library for these now. And we'll click watch 3 times after searching for it. With the watch nodes placed, we can position them to the right of the nodes that we previously placed. And we'll connect the node's output into the watch nodes. This allows us to better visualize the results. Now that we have the out-of-the-box nodes fulfilled with watch nodes to visualize the results, we can now double-click for a code block. We simply double-click anywhere on the canvas to place a code block. For this first node, we'll type in a number 5, and we'll move it to the right. We'll double-click for another code block, type in quote, hello Dynamo, end quote. Once you click outside of the code block node, Dynamo will add a semicolon to the end of the line, but you can also add that manually if you would like. For the final node, we'll double-click for a code block and type 4 asterisk 2. It is important to keep in mind that all statements or lines in a code block must end with the semicolon, so you are able to type that manually, or it should get added automatically when you click outside of the node. In order to see what's going on, we can hover and pin the preview of each one of our code blocks. As you can see, this first code block is outputting a number in the same manner that the number node to the left is. If we move to the next node, we'll notice that this code block is outputting a string element, and that is going to relate to the node directly to the left of it as well. In the final code block, we have an output of the number 8, but within the code block we have a formula. This demonstrates the flexibility of code blocks in the sense that it can hold numbers, strings, or formulas. I'm going to go ahead and delete all of these existing nodes and we'll start over. In addition to using code blocks for strings, numbers, and formulas, you can call any regular node in the library through a code block, as long as this node does not require a special user interface. For instance, if we navigate to Geometry, Curves, Circle, you could call Circle by Center Point Radius with a code block. However, you could not call a node like Watch 3D with a code block. This is because it has a special user interface, so it's not going to be able to preview the way that it should. Regular nodes generally come in 3 types: Action, Create, and Query. In order to better see this, we can navigate to Geometry, Points, Point. Create allows you to create something. That's indicated by this green plus sign in the library. Let's say you wanted to create a point by Cartesian coordinates. That would be located under the Create category. An action allows you to perform an action on something. So let's say that you take a point that you create and you want to project it onto another piece of geometry. That would be in the Action category, and that node can be found under Project. Query allows you to get the properties of an object. So looking at a point element, we can extract its x, y, or z values with the query category of the library. Methods or nodes of these types are treated differently when invoked in a code block. When you use a method to create something, you call it by name and you specify the inputs and the order found in the out-of-the-box node. Let's look at this now by creating a point on the XY plane. So we'll place the point by coordinates node with an XY input. In order to fulfill the inputs of this node, I will go ahead and double click for a code block and type in a number 5. The output of this code block will go into the X input port of the point by coordinates node. As you can see, in our background 3D preview, we have a point getting generated automatically. This is because we fulfilled the X input with a custom number and the Y input has a default value of 0 that we're currently using. In order to see this data, we can also hover over the node and pin the preview. Now, let's double click in the workspace to add a code block and do the same action in a code block. We'll double click. We will specify the object name, which is a point, dot, by coordinates, open parenthesis, 5, 0, close parenthesis. Within the parentheses would be our inputs that we decided to use for this action. Once we click outside of the code block, it will be fulfilled and we can hover and pin the preview and see that it's returning the same object that the node-based version above is. One thing to note is that create type nodes that do not require inputs must still use parentheses followed by a semicolon. In order to better understand this, let's go back to the geometry, points, point category, and place the origin node. And we'll move this node over to the right of the canvas and position the first two nodes over to the left. If we hover and pin the preview of this node, we'll see that it's returning a point at 0, 0, 0, which is the origin of the Dynamo background 3D preview. Let's double click to add a code block and call this object using its name. So we'll double click and we'll type point.origin and we have to put a open parenthesis, close parenthesis. Once we click outside of the code block, it will add a semicolon. We can hover, pin its preview, and notice that we're getting the same element as the point.origin node. Additionally, if you wanted to learn a little bit more about the design script syntax, you can always select a node, right-click on the canvas, and use the node to code function. If we click node to code, we'll notice that not only is it committing the same action of declaring a point.origin element, it's also defining a variable for us. We will cover this a little bit more later on in this lesson. I'm going to go ahead and clear my canvas once again by selecting all of the nodes and pressing delete on my keyboard, and we'll look at a few things as it relates to actions on objects. Dynamo uses dot notation, common to many coding languages that are object-oriented. This allows you to apply an action to an object. For example, if I want to call on the point.add node that's in the action category in a code block, we can see that this particular object here in Dynamo requires a point input and a vector to add. To see how this is working, let's go ahead and add our point origin node, the add node, and a vector.z-axis to the canvas. With these three nodes placed, we can now fulfill the inputs of the point.add node, point to point, and vector to add. If we hover and pin this preview, we'll see that we now have a point that has been moved to 0, 0, 1. That's because we added this vector to the origin point. So if we want to call the point.add node from within a code block, we'll notice that this is an action type of node. Its inputs are the point and the vector to add to it. So in a code block, we'll double click for a code block. We'll name a variable pt. Once we click dot, we can choose the action that we want to complete on the input item. In our case, we'll add. We'll do an open parenthesis and we'll type vec for vector, close parenthesis, click outside of the code block, and we'll have a semicolon added. Once again, you can add that semicolon yourself if you would like. In our case, we received two input ports on this code block that we can now use. The first input port takes a point element, so we can connect that into our point. The second input port would be for our vector, and we'll use that vector as well. With these inputs fulfilled, we can hover and pin the preview and notice that the results are the same as the node-based version above. Once again, I'm going to clear my workspace by selecting all of the nodes and pressing delete on the keyboard, and we'll discuss the query objects within the library. So if we navigate to Geometry, Points, Point, we'll notice that we have a few options in the query category. These options include X, Y, and Z. Query type methods get the properties of an object. Since the object itself is the input, you don't have to specify any additional inputs, and we'll look at this by placing a point.x node. As you can see, this takes a point element as the input and it returns its x value for you. I'll go ahead and remove this node, and we'll add a code block to the canvas. In this section, we're going to create a series of points. In order to achieve this, we can use a range expression. So to get started, we'll declare a variable. In order to declare a variable, we'll type in pts space equals space. We're adding spaces purely for legibility at this point. This allows us to declare a variable to use in the same code block. In our case, we're going to type point dot by coordinates open parenthesis 0.10 to specify the x values, comma 0 just to leave the y values at 0, close parenthesis. In this case, we'll go ahead and type in a semicolon and click outside of the code block. As you can see in the background 3D preview, we've generated a list of points. If we hover on the code block and pin the preview, we can see this reiterated as well. Since we generated a variable within this code block, we can reuse that variable to commit query actions on top of those elements. So what we will do is click after the semicolon, hit enter, and type pts.x semicolon. Once we do this, our preview will change on our code block because we are now returning the x value of those points that we created. Once you begin to understand these core concepts of code blocks, you may begin to utilize them for things such as strings or text, numbers or doubles, or calling on other actions in the library. This enables you to build dynamo graphs that are very clean and adaptable.